Hey guys, welcome to your third lesson from chapter 13. Today's lesson is to actually kind of take a look at the last two unit circle videos that you've been watching on your own. We've already done, hopefully, 2 unit circle videos as well as the first 2 lessons of chapter 13. And if you've watched all of those videos, this lesson should really kind of be a recap of all of that information. If you haven't watched the first and second videos on the unit circle, this is really going to make no sense to you. So you definitely want to make sure that you've taken the time to watch those 2 videos so that you can make some sense of section 13.3. The first thing is in 13.3 is the idea that a unit circle, the circle x squared plus y squared equals 1 has a center at 0, 0 and a radius of 1. And we talked about that before. To create the unit circle, we start at this origin 0, 0, and we swing an arc with a radius of 1, and then we go all the way around 360 degrees to make that circle. All right, and so this circle then has a radius of 1. And we're going to be able to use this unit circle to identify various points in ordered pairs around that, and then use those to find exact trig values. A quadrant angle is an angle in standard position whose terminal side lies on an axis. So for example, a 90-degree angle would be a quadrant angle because its terminal side is the y-axis going up. 180 degrees would be another quadrant angle because we go 180 degrees and its terminal side lies on the x-axis going to the left. 270 and 360 would round out our quadrant angles. There should be 4 of them. All right, and then finally a reference angle. A reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. Extremely important that we recognize when we're dealing with reference angles, what we're talking about is what do we need to get to the x-axis. Okay, whether we need to take some angle away or add some angle, we want to be in relation to the x-axis when we're talking about reference angles. Okay, so let's take a look at some general definitions of trigonometric functions. Okay, first of all, if you have any circle, it says let theta be an angle in standard position and let xy be a point where the terminal side of theta intersects the circle x squared plus y squared equals r squared. Notice that this is for any radius. The radius can be anything we want it to be. It does not just have to be 1. That's the unit circle, which we'll get to in about a page here on this lesson. All right, but for right now, what I want to do is I want to define the 6 trigonometric functions based on having a radius of r, all right, and the radius of r then can be used with the ordered pair x, y on the circle to define the various sine and cosine values as well as the other trig functions, right? So the sine of theta ends up being the ratio of y over the radius, all right? And it has to do with the fact that this angle theta creates a reference angle down here called theta prime. And if I go to the left, whatever this distance is, well, that's my x value. And if I go up, whatever this y value is, that's my sine value. As you guys remember from your second unit circle video, every ordered pair on this circle is cosine theta, sine theta. So in terms of ordered pairs, cosine is going to be related with the x value, and sine is going to be related with the y value. Okay? So because of that, then, we can say that sine theta is equal to y over r, cosine theta is equal to x over r, and the tangent of theta is equal to y over x. Now, in defining the tangent ratio ends up being y over x, all right? And it has something to do with opposite over adjacent. Again, if I was looking at this angle theta prime here, the opposite side would be the height, which would be y, and the adjacent side would be x. Remember that tangent is opposite over adjacent. All right, so in relation to this reference angle, tangent would be opposite over adjacent, which in this case is y over x. All right? Now, there's another way we can define the tangent ratio, which we'll be spending a little bit more time with when we actually talk more about the unit circle. So we'll get to that part on the next page. All right, now if you can recall, the cosecant rather, is just the reciprocal of the sine. And so this simply becomes y over r. The cosine of theta becomes the cosine of theta is x over r, and so the secant is r over x. And finally, the cotangent becomes x over y. Now, keep in mind that in any of these cases, Okay, we can't have a value of y to be 0 because you get 0 in the denominator. for both cosecant and cotangent. All right? The secant, x cannot be equal to 0 because we would get a 0 in the denominator of our fraction, and therefore it would be undefined. All right? And so when we get around these quadrant angles, like 0 degrees, 90 degrees, 180 degrees, and 270 degrees, we know that our sine and cosine and tangent and all of these 6 trig values are going to behave a little bit differently. And it's mostly just because in this case, like for example, this is 0, -1. And so for a 270 degree angle, all right, the x value would be the cosine, 0, and the y value would be the sine, which is -1. And if you were trying to find, like for example, the cosecant, all right, the cosecant of a 270 degree angle would be r over y, and in this case the radius is whatever r is, and then over y, which is -1. So that wouldn't be so bad. But if you're trying to find the secant of a 270 degree angle, the secant of a 270 degree angle would be r over x. So whatever the radius is divided by x, well in this case the radius is 0. And so the secant of 270 degrees is undefined because we can't have a 0 in the denominator of our fraction. So some weird behavior kinds of things, and that really only happens on the quadrant angles. So I think it's just important to mention that you're going to get some goofy values of things around the quadrant angles, 0, 90, 180, and 270. Okay, so let's take a look at this circle. It says, let -12, 5 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trigonometric functions of theta. So what we're saying here is we have some circle, all right, and I doubt that I'm going to be able to do it, but let's try. Yeah, pretend that that's centered at the origin here, all right? And we have some circle centered here, and then the radius is given here, all right? And so that's my radius. And the point -12, 5 is on that circle. And so it says, first of all, we want to evaluate the 6 trig functions of theta. Well, the first thing we need to do is we need to find the length of the radius, keeping in mind that this right triangle can be created by going left 12 and up 5, but distances always have to be positive, so basically it's a right triangle with a side length of 12 and 5. So this becomes 12 squared and 5 squared. Now you can square -12, you better get positive 144, and then 144 plus 25 makes 169, and so therefore the radius of this circle is 13. All right, and so looking back at the previous page, using x equals -12, r equals 5, and r equals 13, we can fill in the 6 trig ratios. We know that sine is y over r. Okay, and so because it's y over r, we just take the y value from the ordered pair, 5, and we put it over the radius, which is 13. The cosecant is the reciprocal of that, which is r over y, and so this becomes 13 over 5. The cosine of theta becomes x over the radius. Well, my x value is -12, and the radius in this case is 13. Okay, the secant would then be radius over x, which is 13 over -12, or simply -13/12. Finally, the tangent becomes y over x. All right, so it's y divided by x. In our case, my y value is 5, my x value is -12, and so instead of saying 5 over -12, I'm just going to say -5/12, and then take the reciprocal of that is -12/5. All right, and so it's pretty obvious that what we have to do here first is we have to find that radius, and then we can just set up our 6 trig values. If you can remember that sine goes with y, cosine goes with x, and then tangent is y over x, I'm going to show you guys a way to remember that a little bit better in the next piece of this, in the unit circle. But if you can remember that, you should be able to take the reciprocals of all of those, because you know that cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Okay, so checkpoint problem next. Give it a shot, see what you come up with. We'll be right back with a solution. Okay, so let's start with a circle here, and let's make our radius. And we have the point, well, let's change that. We have the point 6, -8. Okay, so here's my circle, and if I go right 6 and down 8, maybe it's like right in there someplace. Okay, so that would be the point 6, -8. And here's my radius. We need to know what that is. But we have this angle theta. And we want to use that to establish the 6 trig functions. Well, the first thing we need is radius. And again, if you assume that we make a right triangle here, we go to the right 6 and down 8. Let me change my color there. It might be easier to read. We go to the right 6 and down 8. Who cares that it's negative? Okay, at least not for finding the radius. It won't really matter. It's the square root of 6 squared plus negative 8 squared. This becomes 36 and 64. And the square root of 100 is 10. And so that tells me my radius is equal to 10. All right, so the sine of theta, the cosine of theta, the tangent of theta can be easily defined. And then the cosecant of theta is the reciprocal of sine. The secant of theta is the reciprocal of cosine. And finally, the cotangent would be then the reciprocal of tangent. Okay? Again, y goes with sine, x goes with cosine, and then tangent is y over x. All right? So this is y over the radius. So my y value in this case is negative 8 over the radius, which is 10. The cosine would become the x value, which is 6, over the radius, which is 10. And the tangent becomes y over x. The y value is negative 8. The x value is 6. All right, cosecant. Cosecant would be the reciprocal, so negative 10 over 8. You know what, before I do that, I'm just kind of thinking here. Don't forget that all your fractions should always be in lowest terms. I don't want to flip all of these over and then have to reduce twice, so I'm going to reduce them right now. This is equal to negative 4 fifths. This is equal to 3 fifths. And this is equal to negative 4 thirds. All right, and then you would just take the reciprocals of all of those. So this is negative 5 fourths. This would be positive 5 thirds. This would be negative 3 fourths. All right, and so those are 6 trig ratios based on having that radius and those lengths of those sides. Okay, so again, make sure that when you get done here, you reduce, and you should be in pretty good shape. Now, let's jump into this unit circle deal, because we've been talking about the unit circle for the last couple of days in your videos. Basically, the unit circle is this circle. The equation is x squared plus y squared equals 1, and all it says is we have a circle with a radius of 1 centered at the origin. Okay. Now, if you go back to the previous page and you look at some of your ratios from before, we said that the sine value is y over r. Well, in a unit circle, the radius is 1. Well, if the radius is 1, that becomes y over 1, or simply y. The cosine is x over the radius, which is x over 1, which is simply x. Now, I want you to have this on here because we know that the tangent value, the tangent of theta, is y over x. All right? And we've been talking a little bit in your unit circle videos, and I said that every one of these ordered pairs is cosine theta, sine theta, where the x is the cosine and the y is the sine. Well, instead of saying y over x, we can say that the sine of theta divided by the cosine of theta is another way that we can define the tangent ratio. All right? And so we'll be able to use that to compute exact trig values based on the unit circle that we filled in the last couple of days. And with that information, and I should be able to ask you for the sine, cosine, and tangent of any of those angles on my circle, and we should be in pretty good shape to go ahead and give those values. All right? So this is a hugely important concept, and I would probably write that on my unit circle that I filled in, and it's an important concept that you guys should be aware of, something that you should know. All right, so let's use a unit circle. It says use the unit circle to evaluate the 6 trigonometric functions of 450 degrees. Okay, so we've got our unit circle drawn to the left, to the right here. 450 degrees is more than a full circle, so let's go 450 minus 360, and that comes out to 90 degrees. All right, so what we're saying then is I take and I go one full circle plus another 90 degrees. So that would be a 450 degree angle. All right, in this case, the ordered pair is 0, 1. So the x value is 0, the y value is 1. All right, so the angle theta intersects the unit circle at the point 0, 1. And so x is equal to 0 and y is equal to 1. And we know that the radius is equal to 1 because it's a unit circle. Okay? And so the sine of theta then becomes y over the radius, or simply just y, and the y value in this case is 1. All right? The cosine of theta, well, the cosine of theta ends up being just the x value, and the x value in this case is 0. The tangent of theta, as I said before, is sine over cosine, so you can think about it that way. It's simply sine over cosine, which is 1 over 0, which is undefined. Okay? Or what you could do is you could say it's y over x. In our case, y is 1, x is 0, and it's also, again, undefined. Okay, now keep in mind that this is 1 over 1, this is 0 over 1, all right? And so if I take the reciprocal of that to find cosecant, this would be the reciprocal of 1 over 1, which is still 1 over 1. Okay, since our case is 1. All right, the reciprocal of the secant would be r, in our case, which is 1, over 0, and 1 divided by 0 is undefined. And then finally, the cotangent would be the reciprocal, which would be 0 over 1, which 0 divided by 1 is okay, that's 0. All right, because again, the cotangent is the reciprocal of 1 over 0. Now, remember before when I told you, when you're landing on these these quadrant angles like 90, 180, 270, and 360, you're going to get some goofy things that happen, and it's mostly just because you end up with zeros in the top and bottom of the fraction. And so for that reason, you got to be real careful around the quadrant angles when you're defining sine, cosine, and tangent. Okay? So there's a checkpoint problem here down below. They want you to fill in the 6 trig functions for 360 degrees. So let's go ahead and try that together. First thing I would do is I would draw a unit circle, and I would put the center here. 360 degrees is a full rotation all the way right back to here. So theta is going to intersect at 1, 0. So my x value is 1, my y value is 0. I know that sine theta, or in our case, sine 360, is going to be equal to the y value, which in our case is 0. I know that the cosine of 360 is going to be equal to the x value, which in our case is 1. And so therefore the tangent of 360 is simply sine 360 over cosine 360. And the sine of 360 is the y value, so that's 0, over the cosine, which is 1. Okay, and so it's basically 0 over 1. Now, if I want to go ahead and find the reciprocals of those, okay, if I want to find the, sorry, I'm going to slide this over just a little bit. If I want to go ahead and I want to find the cosecant, the cosecant of theta, I'm just going to call it theta because it's easier to write, would be the reciprocal of 0 over 1, which is 1 over 0, which as you know is undefined. All right, the secant of theta, and be careful, I'm just noticing as I'm writing this, theta is this. This is undefined. So if I kind of put it on an angle, I should probably write out the word undefined. Okay, but I don't have enough room, so you guys are going to have to deal with that, okay? All right, the cosecant is the reciprocal of 1 over 1, which is simply 1 over 1, or 1. And then the cotangent, okay, the cotangent would then be the reciprocal of 1 over, or 0 over 1, which is 1 over 0, which is also undefined. All right? So that is the gist of using a unit circle. Now I want to take a look at this idea of a reference angle, because we've talked a little bit about reference angles in this lesson already. And they give you this long, drawn-out box where you're supposed to remember all of these rules and how do you find reference angle relationships. You know, my point is and what I think about is I say, look, how do I get the angle I have to an x-axis? Okay, what do I need to go with it to get to the x-axis, or what do I need to take away from it to get to the x-axis? Specifically, if I have an angle in the first quadrant, okay, the reference angle for that angle is the angle in the first quadrant, because that's what it takes to get to the x-axis. If I have a 45-degree angle, well, it's 45 degrees off the x-axis. So another way to say this is how many degrees, or I suppose radians, are you off the x-axis? And it's extremely important that we define it based on the x-axis, because that's going to play into the values of my x's and y's, which are these points around the circle. All right, so how far is it to the x-axis? How many degrees do you need to get there? So in quadrant 2, if you have an angle here in quadrant 2, what they say is look, if this is, for example, 150 degrees, how many degrees do I need to go with that to make 180 degrees? Well, the rule then says take 180 and minus theta. In radians, since 180 degrees is the same as pi, they say take pi, subtract theta. Now again, I'm not into remembering all of those rules, okay, because I don't want to remember 3 separate rules for each of the quadrants. All I'm going to say is how much more do I need to get to either pi or 180. If I'm in the third quadrant down here, well, now we say how much more are we past 180? Or, for example, how much do we need to get back to 180? So if I had a 230 degree angle, A 230 degree angle puts us into the third quadrant. Well, if I do 230 minus 180, that tells me that I am 50 degrees past 180 degrees. So the reference angle for that is simply 50 degrees. All right? So the rule on here says take the angle, subtract 180. Take the angle and subtract pi. Well, again, I don't like to think about a separate rule. I'm just going to say how many degrees am I off the x-axis? All right? And maybe I should be really specific and say how many degrees am I off the closest x-axis. But I'm pretty sure you guys are I'm pretty sure you guys wouldn't subtract it and try to get it to this x-axis. At least I hope not. All right, what about in the fourth quadrant? If I have this angle, again, for example, let's do something like 11 pi over 4. All right? I'm sorry, 11 pi over 6. Sorry about that. So let's take 11 pi over 6, for example. 11 pi over 6 I know is going to put me in the fourth quadrant, all right, which is down here someplace. And I want to know how many degrees is it going to take, or how many radians is it going to take to get me to the x-axis. Well, I know the x-axis is 2 pi, right? So if I take 2 pi and I say, all right, well, 2 pi minus 11 pi over 6, well, 2 pi is the same thing as 12 pi over 6. So that becomes simply pi over 6. So that says I'm pi over 6 radians away from the x-axis. Okay, if you want to do that with angles, that's the same thing as 330 degrees. Okay, and 330 degrees is 30 degrees off the x-axis. And if you look at your unit circle, guys, you should find out that pi over 6 and 30 degrees are the exact same thing. All right? So let's find a couple of reference angles, and then we'll call it quits for this lesson, because the last page of this I think we can do together in class. Okay? All right, so the first thing they want us to do is they want us to find the reference angle for negative 165 degrees. So the first thing I want to do is I want to draw that. Okay, I want to draw a 165 degree angle. I'm sorry, a negative 165 degree angle. Listen, 165 degrees, if I'm going negative, means go clockwise. So if I go 90 plus more, but I can't quite go to 180 because that's going to put me all the way to 180 degrees, right? So somewhere like right in here, all right? So that would be a negative 165 degree angle, all right? And then what we could also do is we can say, all right, well, let's write that as a positive angle. Isn't that the same thing as 360 minus 165 to say that this is a 195 degree angle? Is that true? All right, so if this is a 195 degree angle in the positive direction, let's kind of think of it from the other side. This is 195 degrees. Now, again, when I talk about reference angles, I say, how much do I need to get back to an x-axis? Well, as you can see, 195 is 15 degrees more than 180. 195 minus 180 becomes 15 degrees. All right, so they want to use the rule and all this kind of stuff. You know what? Blah, 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 blah. Okay, what I'm going to do is I'm going to say, look, this is 195 degrees, which is 15 degrees more than 180. So the reference angle for that is 15 degrees. All right, let's do another one of these. Let's do another one of these for my other angle. My second angle that I'm looking at here, and pretend I hit the middle here, is 7 pi over 4. Now, if you use your unit circle, you know that 7 pi over 4 is down in here someplace. All right, that is 7 pi over 4. All right, 7 pi over 4 radians says I'm going to go all the way around there. And guys, remember, I know that 8 pi over 4 is the same thing as 2 pi, which is a full circle. So that's why I know it's down here in the fourth quadrant. So then we just say, all right, look, how far do I need to go to get to the x-axis? How many degrees do I need? In this case, how many radians do I need? Well, I simply take 2 pi and I minus 7 pi over 4. We just said 2 pi is the same as 8 pi over 4. Again, 8 divided by 4 is 2, right? So what's 8 pi over 4 minus 7 pi over 4? Well, as you can tell, 8 pi over 4 minus 7 pi over 4 is simply pi over 4. And so this angle right here would be 7 pi over 4 radians, because that goes with 7 pi over 4 to make a full circle. Okay? So that's reference angles, and that's really the gist of that lesson. Now, the last page of this, I think, is kind of important, and we'll spend some more time filling in this chart because, quite frankly, this is a little confusing. All right, so you're looking at all of that stuff. We'll define this a little bit better when we talk in class, because we can take a look at the various quadrants and look at the signs of those function values in those various quadrants. And here, what they're going to ask you to do is they're going to ask you to find the reference angle, then go ahead and find sine, cosine, or tangent, and then look at our little signs chart and figure out if it should be positive or negative. And I'm telling you, we can do this a lot easier with our unit circle. Okay? So we're going to refer to our unit circle to do this, and we'll do this part together in class tomorrow.